When we construct the confidence interval, we find the interval that captures the true unknown parameters, proportion, mean, or standard deviation, or whatever the parameter that we are trying to estimate. For the proportion, we find the left and the right bound, or the lower or the upper bound, so that the proportion, true proportion, unknown proportion is between the left and the right bound. Or for the mean, we use mu left less than or equal to mu less than the right bound, and so on. And so this interval captures the true unknown parameters. We construct the confidence interval by taking the corresponding statistics. For the proportion, we would use p hat plus or minus the margin of error. And for the mean, we would use x bar plus or minus the margin of error. The margin of error for the proportion m is computed by taking the critical value z star times the standard error p hat times 1 minus p hat over n. For the mean, there are two cases. If sigma is known, then we would take the sample statistics x bar plus or minus the margin of error is now z star times sigma divided by the square root of n. And if sigma is unknown or not given in the problem, then the confidence interval is x bar plus or minus t star times h divided by the square root of n, but the degree of freedom is 1 less than the sample size, n minus 1. What the confidence interval is telling us is that we are certain 95%, 97%, or some percentage of confidence that the true unknown parameters is within the two numbers. Anything that is within these two numbers is considered as usual. Anything that is outside is considered as unusual. When we perform hypothesis tests, we can also construct the confidence interval to draw the conclusion for the hypothesis test, but the conclusion is about the null hypothesis. Anything that is outside of the confidence interval, we would reject the null hypothesis. So this is known as the rejection region, where we reject the null hypothesis. And anything that is inside is the fail to reject the null hypothesis region. If the significance level alpha is not given, then we would use alpha equals 0.05. The confidence level is always 1 minus alpha. And so if alpha is given to be 0.01, then the significance level is 0.99, because 1 minus 0.1 is 0.99 or 99%. But this confidence interval had two tails, so it corresponds to the two-tailed test. Don't do this if the test is the left or the right tail test. If we really want to construct the confidence interval for the one-tailed test, then the confidence level would have to be 1 minus 2 times alpha. This is for the left or the right tail test alone. Normally, we would not construct the confidence interval for the one tail test. Again, we would do this for the two tail test.